Today we're going to be talking about work rate problems, and I'm going to give some example questions and we're going to solve them together. First, let's read the question. A painter can paint a house in 6 hours. Another painter can paint the same house in 4 hours. How long will it take them to paint the house together? Now let's use some thinking before we do anything. Let's say that I'm the painter that can paint the house in 4 hours, and you're the painter who can paint the house in 6 hours because you're not as good as me. If I can paint the house in 4 hours, but I want a little extra help, so I hire you who can paint the house in 6 hours, why would I hire you? Why would I want to paint with you if I know that us painting together is going to result in us taking longer to finish painting the house? Anyways, just something to think about. Our final answer should be less than 4. Alright, anyways, let's get started. First, I want to talk about an equation that you should remember. Work rate multiplied by the time equals work done. Right now, we're only talking about this to keep things simple. The red painter, he can paint a house in 6 hours. What's his work rate? I don't know, you tell me. Let's just say it's X for now. Now, what's the time? 6 hours. Work done? That's 1 because he's painting one house. He's finishing one job in 6 hours. So would you look at that? We already have an equation here. 6x equals 1. Now what does x equal? Now you can tell me. We divide each side by 6 and then the two sixes cancel out. So we're left with x equals 1 over 6. That's the work rate. Therefore, the red painter's work rate is 1 over 6. Now, if you want to understand this on a deeper level, I guess I can explain it to you. Let's say that all of this progress is what takes the red painter to finish painting the house. All of this counts as one job done. Now we're going to split this into 6 sections. 1, 2, 3, 4, 5, 6. Each of these sections is 1 over 6. Now because there's 6 of them, 1 over 6 times 6 equals 1. Now that's why this is his work rate, because this is how much work that he is getting done in 1 hour. That's his work rate. If he were to be working for 2 hours, then you're going to add another section, and then you get 2 over 6. 3 hours, you got another section, you get 3 over 6. But his work rate is how much of the work he can get done in 1 hour. That's why it's important to memorize this equation, because it's going to help you through every single question like this. A way to shorten it down, you can just say WR times T equals WD. That's what I usually write. Anyways, enough of this nonsense. Let's talk about this painter. Now this painter is going to be the blue painter. Alright, so we already went over work rate times time equals work done, and I hope with this you can see to calculate the work rate, you simply just divide the work done by time, and then you'd get the work rate. Now the blue painter, he can paint the same house in 4 hours, so his time is 4, his work done is 1 because he's getting one job done, and his work rate's 1 over 4. His work rate is 1 over 4. Let's go over the red painter once again. He can paint the house in 6 hours. That's going to be 6 in time. Still 1 for work done. And his work rate is 1 over 6. Now we're not interested in any of this. Okay, we're only looking at the work rates here. So we're going to add up their work rates together. Now that they're working together, they're going to have a new work rate. And we don't know what that work rate is, but all we know is that it's going to be 1 over something. So we're just going to put x. Alright, would you look at that? We have another equation to solve. So we're going to solve this by looking for the LCD, least common denominator. And in this case, it's 24x. Alright, let's multiply everything together. I'm just going to move this over here for now. Let's start off by multiplying the LCD into every single one of these fractions here. Okay, I had to move quite a few things around. So 4 goes into 24 6 times, and multiply the x as well. 6 goes into 24 4 times, add on the x, and then x and x cancel out, and we're left with just 24 times 1, which is 24. 6x plus 4x equals 10x equals 24. Divide both sides by 10, and then we get x equals 24 over 10. You can simplify this, but you can also just turn it straight into a decimal, and because it's still going to look fine as a decimal, I'm just going to turn it into a decimal. Remember, any number divided by 10, you just move the decimal back one number. And then you get your answer, 2.4. So all that to find out that 1 over 4 plus 1 over 6 equals 2.4. Now what do we do with this information? This right here, this is their work rate. Their new work rate when they both work together. So from this you can see that to paint the house together, it's going to take them 2.4 hours. Now let's see why by using this equation once more. Okay, so I simplified it a little bit. As I said, I usually write it as WR times T equals WD. It's just going to save you just a little bit of time. So what's the work rate? Well, that's exactly what we just calculated. 1 over 2.4 times the time. The time is whatever's at the bottom, which is 2.4. Work done, it's always going to be 1, unless if you're painting multiple houses, which is not what we're doing here. So from here you can see 2.4, that's the time. That's how long it will take them to paint the house together. Now remember that for all the time that we have used here, we have been using them in units of hours. I just haven't been writing that down because I feel like that would make things a little more complicated. So yeah, 2.4 hours is how long it will take them to paint the house together. You can't just stop there unless if the question asks you exactly like how much hours, how much minutes. We could calculate how much minutes that is. I'm just gonna erase all of this. 2.4 hours. We can split that into 2. That's 2 hours and 0.4 hours. Now we already have this set aside. We're just trying to figure out how much 0.4 hours is in minutes. Now let's think about the ratio between hours and minutes here. 1 hour is equal to 60 minutes. So if we have 0.4 hours and we want to figure out how much minutes that is, we're going to cross multiply. So we're going to multiply these two first. 0.4 multiplied by 60 equals 24. Now we divide by the 1 hour, and anything divided by 1 is the same number, so we get 24 minutes. Therefore, it will take them 2 hours and 24 minutes. And that's how you would solve this problem. You can either write 2.4 hours or 2 hours and 24 minutes. It really depends on if the question implies that you have to convert it into X hours and X minutes form, but if not, you could totally just write it as 2.4 hours. Alright, next question. Ronald wants to replace the water in his pool with clean water. He drains his pool in 5 hours, then he refills it again in 7.5 hours. He then discovers that the pool drain was open the entire time, so Ronald's just stupid. How fast could he have filled the pool if he wasn't stupid and useless? First off, we're going to use the same equation. This one right here, work rate times time equals work done. Now this question is really long, but I promise it's not that deep. We're given that it takes 5 hours to drain his pool, and we're also given that with the drain and the hose to fill up the pool, it takes 7.5 hours. And we're just trying to calculate how long it would take to refill the pool with just the hose itself. So while he is refilling it, he has two things going on at the same time. He has the hose that fills up the pool, and he has the drain open. So F for fill, D for drain, and that results in both of them working at the same time. So we're going to say B for that. So we don't know how long it would have taken to fill up the pool with just the hose to fill the pool itself. So we're going to say that that's X for time. And work done is always going to be 1, and the work rate is going to be 1 over X. Now for the drain alone, we know that the time is 5 hours. Work done is 1, so the work rate is 1 over 5. And we're also given how long it takes for both to be working at the same time, which is 7.5 hours. So for both here, we're going to put 7.5. It's still going to be 1, and the work rate is 1 over 7.5. Now, I want you to think logically here. Him having the drain open while he was refilling the pool, that's not a good thing. The drain is working against his goal of refilling the pool. So for the question that we did earlier, both of the painters were helping each other reach their goal. So we added up both of their work rates. However, here, the only work rate that is actually doing something productive is the action of filling the pool, but draining the pool is reducing the work rates of refilling the pool. So instead of adding up the two work rates, we're going to subtract the refilling work rates by the draining work rate. So this is what the equation would look like. we're going to have 1 over x minus 1 over 5 equals 1 over 7.5. Now let's think logically here again. If it takes him 7.5 hours to refill the pool while the drain is open, then we can assume that it would take him less time to refill the pool without the drain being open, because there isn't anything disrupting the work of filling up the pool. So we can confidently say that our answer is going to be less than 7.5 hours, because it wouldn't make sense if you close the drain and your pool refills even slower. That being said, let's solve this. The LCD is going to be all of the denominators multiplied together, which is going to give us 37.5x. So now let's multiply the LCD into all of the fractions. Alright, so now that we have a 37.5 hanging next to every single one of the fractions, let's multiply them. Here the two x's cancel out and we're just left with 37.5. And here 5 goes into 37.5 7.5 times, and we're going to carry on the x. And here 7.5 goes into 37.5 5 times, so it's going to be equal 5x. Alright, now let's solve for x. We're going to move the 7.5x from the left side to the right side by adding 7.5x to both sides. So then we get 37.5 equals 5x plus 7.5x, which is going to be 12.5x. Now we're going to isolate the x. We're going to divide both sides by 12.5. So then we're going to be left with x equals 37.5 over 12.5, which is going to be 3. So therefore, if we plug this 3 into here, we can see that the work rate of just filling the pool with no drain would be 1 over 3. And that means that it would have taken Ronald 3 hours to fill the pool if he had remembered to close the drain. And that's it for work rate problems. I did go by this one just a little bit faster because I went through most of the stuff in more detail in the previous question. So yeah, that's about it. I hope you enjoyed this video.